All right, today we're going to look at combining like terms. So like terms are terms that contain the same variables with corresponding variables having the same power. All right, so we have a few words in there that we're probably not used to using. Terms. An example of terms, 4x and 3. These are examples of terms. Variables. You guys probably know what a variable is. What's an example of a variable?
A letter.
A letter. So x and y. Those are both examples of variables. Powers.
The two.
The two. That's also called the what? Exponent. Very nice. So if something's raised to a power, it has an exponent. All right, so we have this table. 4x and 3 are not like terms because the second term has no variable. So if we were asked to simplify it, we wouldn't be able to do anything. We couldn't combine the 4 and the 3. 4x and 3y are not like terms. The second term now has a variable, but it doesn't match the variable of the first term. The variables are different. Can't simplify it any more than that. 4x and 3x squared are not like terms because the second term now has the same variable, but the degree is different. This is raised to the first power, even though the 1's not there. This is raised to the second power. Cannot add or subtract them because they're not like terms. 4x and 3x are like terms. Now the variables match and the degrees match. So if we were to add these, we would add the numbers that are in front. All right, so example 1. Determine if the following are like terms. 2x and x squared. Like or not?
No.
Why?
Because the x has a power or an exponent,
Right.
and the other one doesn't.
Correct. 3x and 2x. Like or not? Like. There's an x after both the numbers. They're both raised to the first power. 4 and negative 6.
Yes.
Can't combine these?
Yes, you can.
Yeah, you
There's
can.
no X.
But there doesn't have to be an x in order for it to be a like term. So these are like terms.
2x
and 2.
No.
Why not?
One
One has an x, one does not. All right, so combining like terms. That means we are adding or subtracting the coefficient of all the terms that contain the same variable. definition don't we use very often? Coefficient. So the coefficient is the number here that's in front of the x. These are coefficients. So this definition is saying that we add or subtract the numbers, these numbers that are in front of the variables. So example 2, negative 2x plus 4x. First we have to look at it and ask ourselves, are they like terms?
Mm-hmm.
They are like terms. So now let's simplify it. Negative 2x plus 4x, we add or subtract the coefficients. It would be
2x.
2x. Very nice. Example 3. You didn't get it, but you get it now.
You add.
Oh, I get it.
Negative 2 and 4. Maggie gets it. Alright, example 3. Negative 3b minus 2b plus 4a. So do we have like terms?
Mm-hmm. Yes.
Yeah.
Are they all like terms?
No.
No. So what like terms do we have?
Negative 3b, 2b.
So it's negative 6 plus 4. Negative 6b.
No, it's negative 5b plus
Negative 5
4a.
minus.
Negative 5b
Plus 4a.
plus 4a. We can't put these, combine these any further down, so it stays like that.
This is like those typical you're doing algebra.
2x squared plus 3x. Are they like terms?
No.
Nope.
Is it as simple as it gets?
Yes.
Yeah.
So it just stays 2x squared plus 3x because they're not like terms. Alright, now we're going to solve. We're going to look for our like terms, put them together, and then solve the equation. So on the left-hand side, we have 4x minus 5 minus 3x. Do we have like terms?
Yes,
Yeah.
4x and 3x.
So we have
6x
4x
minus 5
and the 3x. Now, you need to pay attention to the fact that there's a minus sign in front of the 3x. Any sign that's to the left of a number stays with that number. So we have 4x minus 3x, which gives us
Negative 1x.
Just 1x.
just 1x. What do we have remaining on the left-hand side? Minus 5
Equals 20.
equals 22.
That's all we do.
What's our next step to solve?
Oh, there's a back.
All we do is solve.
Add 5. It says solve.
Oh,
Dang it.
So 1x equals 27. Very good.
That's so
You do not. It is the same thing as x equals 27.
I really like this
This is not even.
Yay.
really is.
Alright, example 6. Example 6. We have negative 6 plus 2x plus 5, bless you, equals negative 17. What like terms do we have?
6, negative 6.
Negative 6 and 5. So that simplifies to what?
Negative
Negative
1.
1.
Negative 1. What else do we have on the left-hand side?
2x.
Plus 2x
Negative 17.
equals negative 17.
And we have to solve it now?
Now we have to solve it.
So you
So
subtract 2 from
No, you add 1.
Add 1.
Add
Add 1.
Oh, you add 1.
1's cancel. 2x equals
Negative 16,
negative 16.
Would we divide it by 2?
Now we divide it by 2.
which equals negative 8.
Negative 8.
That's easy.
Example 7. 6x plus 12 minus 8x equals negative 2. What are my like terms?
We would add the negative 8x and negative 6x together.
Very good. And that gives me what?
Negative 12x. Or,
Plus
oh
12
yeah.
Negative
That's what I
14x
meant.
plus 12
plus 12
equals negative 2.
equals negative 2.
Then you subtract
Subtract
12
12.
from
Yep.
both sides.
And then we get negative 14.
So we have negative 14x equals
Negative 14.
negative 14.
So divide
And
by
once you divide
14
14 by
x
both,
equals
Negative
X equals
14.
1.
X equals 1. You guys are masters.
algebra out loud. I'd be
We know.
Example 8. 3y minus 5 minus 4y equals 10. What are my like terms? 3y,
negative
4y. So I have 3y,
So negative 1y.
negative 1y,
Minus 5
minus 5
equals 10.
equals 10.
Then you add
Plus
5 to
five.
both sides.
Add 5 to both sides.
That'd be 15.
Then negative 1y equals 15.
Do you have to
Wait, what would we do? Divided
It
by
can't be
what?
negative.
Negative 1.
If I multiply both sides by negative 1, will this become positive? If I divide both sides by negative 1, will the y become positive?
Yeah.
Either way works. We're used to doing the division, and that's fine. Okay? But it only with the negative 1 does it work both ways. That's a really good question. So divide both sides by negative 1, and y equals
15.
negative 15.
Oh, nice.
Oh gosh.
Example 9.
Oh, the next one maybe.
What do we have that's different here? Parentheses. So we have to do that D word, which is
Oh, distribute.
distribute. So,
Yes.
is the 12x involved in the distributing?
No.
Okay, so bring the 12x down.
And then 3 times x and 3 times.
What's in front of the 3?
X.
Negative.
Oh, negative. Oh, I saw the X.
So, we have negative 3 times x, which gives us
Negative 3x.
negative 3x. Bring down the plus,
Plus
and I have
3 and then 3 times 5.
negative 15. Very nice. Am I done distributing?
Yeah.
Yes or
Equals
no?
48.
Yeah.
Yes. Equals 48.
Fine.
All right, now, do I have like terms?
Yeah.
What do I have?
Well, that's the 3x.
12x and 3x. So 12x minus 3x simplifies to
9x
9x.
plus 15.
Now, you have a plus negative 15. So you can leave it like that if you want to, or we can write it as
Minus 15.
minus 15 equals 48.
Wouldn't you add 15 to both sides?
Yes?
9x equals 48. Divided by 9.
No.
So I have 9x equals what?
What's 48 divided by 9?
60 what?
68.
Not 68.
48.
63.
63.
Oh, what? How's that happen?
Yeah, why? We added 15.
X equals 7. Just saying.
Just saying.
Just say it.
So x equals 7.
Just saying.
Sorry.
All right, example 10. What do I need to do first?
You
Bring the
Just
plus
do
y
it.
down.
So what do I have first?
5 times 1.
Bring down what? Minus sign, and then I have,
5 times 4.
which is
20.
20
Plus y.
plus y
Equals
equals negative 8. Now I have to put together what?
the 8 and the 20. Negative. Wait, no.
5y and the y.
I didn't say that.
But can we add 20 to 8 right now?
You can.
That's what it equals, though.
But we can still move it first if we want to.
Okay.
That's fine with me. The 20s cancel. What do I have remaining on the left-hand side?
5 y.
Plus 1.
Plus y equals
Negative 12. Wait,
14.
Isn't that 18?
I did it wrong.
18.
Wait, 12.
Yes, it'd be 12.
Oh.
We can do algebra, but we can't add. That's
Exactly.
awesome. What do I have on the left side?
Can we
Y
make it
is
6y?
6y.
It is 6y. Remember, there's an imaginary 1 right there. So this
Oh,
becomes
yeah.
6y equals 12. What do I
and
do
then
to
we
both
divide it by
sides?
6, and then
Y
x, y
equals
equals
12.
2.
I mean 2.
Again, simple math.
Yeah,
This
first.
doesn't work.
Right, the simpleness we can't get through.